millions or billions or so of bits where you actually get some savings. So it may seem a little silly to you at this point, but the idea is actually the same. And so if we think in terms of a picture, so here we have a picture, and it's a bunch of pixels, right? I mean, that's what a picture is. It's a bunch of dots. Here we're showing one in black and white, so we have black pixels and white pixels, and so we use 1 and a 0 to represent the black and the white. Usually what you have is you'll have 8 or 24 or whatever pixels to bits for every pixel to then bring in color. But of course we're doing a simplified version here, so we're just doing this. We're thinking in terms of black and white, and so if we took a silly contrived picture like we have here, that's a bunch of white pixels and a bunch of black pixels and then a bunch of white pixels and a bunch of black pixels. What we're going to do is what's known as run length image compression, and here's how we describe it. So the very first character, right, will tell us whether we're going to have a collection. Like this says, if we were representing white as 0, it's like, oh, hey, we're going to have a whole bunch of zeros here, like 2, 4, 6, 8, 10, 12, 14. We're going to have 16 zeros here, right? And so the very first thing I'll do is say, all right, we've got a bunch of zeros. And then, and I'm going to do this in 8 pieces of information, which will be a byte. All right. And so the first thing will be, okay, we got a bunch of zeros. Now, what we'll put in here will be a count of those zeros. But the count will be base 2, that is in binary. Right? So in this case, we've got zeros, and we got the units, so we got the 2s, and we got the 4s, and the 8s, and the 16s. All right, so that